Solve the equation e to the power y plus 1 multiplied by cos x dx plus e to the power y sin x dy is equal to 0. So first we compare the given equation by m dx plus n dy is equal to 0. Here we can see that the coefficient of dx is capital M. Here the coefficient of dx is e to the power y plus 1 multiplied by cos x. So m is equal to e to the power y plus 1 multiplied by cos x. Similarly, here the coefficient of dy is n. Here the coefficient of dy is e power y multiplied sin x. So n is equal to e to the power y sin x. Now we differentiate m partially with respect to y. So del m by del y here. When we differentiate this e to the power y plus 1 multiplied by cos x with respect to y, so this cos x is constant. So here cos x is constant, and when we differentiate this del by del y of e to the power y plus 1. Now this is cos x, and differentiation of e to the power y with respect to y, this is e to the power y, and differentiation of 1 with respect to y, this is 0 because 1 is constant. So it can be written as e to the power y multiplied by cos x. So del m by del y is equal to e to the power y multiplied by cos x. Now we differentiate this capital N partially with respect to x. So we get here del n by del x. When we differentiate this e to the power y multiplied by sin x with respect to x, this e to the power y is constant. So this can be written as e to the power y multiplied by del x of sin x. We know that differentiation of sin x with respect to x, this is equal to cos x. So this can be written as e to the power y multiplied by cos x. Here we can see that del m by del y is e to the power y multiplied by cos x, and del n by del x, this is equal to e to the power y multiplied by cos x. That means these are equal. So we can write here del m by del y, this is equal to del n by del x. This shows that the given equation is exact. This shows that the given equation is exact. This shows that the given equation is exact. Now we find out the solution of this equation. So solution of this given equation is integration of m dx plus integration of n1 dy is equal to c. Here n1 is obtained from n1 is obtained by n, and taking those terms in which x is absent, Here n1 is obtained from n1 is obtained by n, and taking those terms of n in which x is absent. Now here m is given by e to the power y plus 1 multiplied by cos x dx plus n1. Here we can see that n1, this is equal to, here n1 is obtained from n, and here we can see that x is present in this term, so n1 becomes 0, and this is equal to c here. Now we integrate this e to the power y plus 1 multiplied by cos x with respect to x. So here e to the power y plus 1, this is constant with respect to x, so it will be outside the integral sign. Integral of cos x dx is equal to c. Here c is the integration constant. So e to the power y plus 1 and integration of cos x, this is equal to sin x, this is equal to c. So this is the solution of the given differential equation. Here we can see this n1 is obtained from n, and we take those term of n in which x is absent. So here in n there is only one term, and in this term x is present, so n1 becomes 0. Now we integrate only m with respect to x and equating arbitrary constant c. So we get e to the power y plus 1 multiplied by sin x is equal to c. Now we solve the second question, that is 1 plus e to the power x by y dx plus e to the power x by y multiplied by 1 minus x by y dy is equal to 0. First we compare this equation by m dx plus n dy is equal to 0. Here we can see that coefficient of dx is m. Here coefficient of dx is 1 plus e to the power x by y. So m is equal to 1 plus e to the power x by y. Here the coefficient of dy is n. Here the coefficient of dy is e to the power xy multiplied by 1 minus x by y. So n is here e to the power x by y multiplied by 1 minus x by y. Now first we differentiate m partially with respect to y. So here 1 is constant with respect to y, so differentiation of 1 is 0. Here we differentiate e to the power x by y with respect to y partially. Here we can see that differentiation of e to the power x with respect to x is x, e to the power x. So here the differentiation of e to the power x by y is e to the power x by y. Now we differentiate this x by y, so x is constant and differentiation of 1 by y with respect to y is minus 1 upon y square. Now we differentiate n partially with respect to x. So here two functions, here product of two functions, one is e to the power x by y and second is 1 minus x by y. So here we use differentiation of product of two functions. So first we write first function, that is e to the power xy, then differentiate 1 minus x by y, plus second function 1 minus x upon y and d by del by del x of e to the power x by y. Now we can see here this e to the power x by y, when we differentiate 1 with respect to x, this becomes 0 because 1 is constant with respect to x, and when we differentiate x by y with respect to x, so 1 upon y is constant because here we differentiate partially, and differentiation of x with respect to x, that is 1. Similarly in this term 1 minus x by y, and when we differentiate e to the power x by y with respect to x, so this is e to the power x by y. Now we differentiate x by y with respect to x, we get 1 upon y as a constant, and differentiation of x is 1. Now in these terms we can see here e to the power x by y is constant, so we e to the power x y we take common here, so this is e to the power x by y, here minus 1 by y, and this 1 upon y multiply in this bracket, so multiplied by 1 we get plus 1 upon y minus x by y square. So this minus 1 upon y plus 1 upon y is cancelled out, so this equal to minus x upon y square e to the power x by y. This is del n by del x. Here we can see that del m by del y, this is equal to del n by del x. So the given equation is exact. Here the given equation is exact. Now we find the solution of the given differential equation. So solution can be written as integration of m dx plus n1 dy is equal to c. Here we know that n1 can be obtained from n, and we know that we take those terms from n in which x is absent. So n can be written as 1 plus e to the power x by y dx, and here n1 becomes 0 because there are two terms and in each term there will be x, so n1 becomes 0 is equal to c. Here we integrate this 1 with respect to x, we get x, and when we differentiate this e to the power x by y with respect to x, we get e to the power x by y, and we know that when we integrate this, when we integrate e to the power x by y, the constant term will be in the denominator. Here the constant term is 1 upon y, so here we write 1 upon y, this is equal to c. So this can be also written as x plus y multiplied by e to the power x by y is equal to c. So this is the solution of the given differential equation. Thank you.